So, shall we get started then? So, welcome everybody to this overview of industrial IoT, provided by Flanders Make and co-financed by the European Commission, the European Union. I'm Valentijn de Leeuw. I'm project lead at Flanders Make, and I have two colleagues with me, Serena Farouk. She will present herself.
Okay, yeah, hello, I'm Serena. I am a project manager and I manage the Reboot Skills project, which delivers this course. I wanted to give a quick heads up about the options available in this meeting room. So we do have a Q&A. If you want to write a question, you can also write your question in the chat. And if you'd like, you can also indicate whether you would like to ask the question on video, or if you'd like me to read it. Thank you.
Then we have Nathalie Bullens, communication officer who is muted. You're both muted, guys, yes?
Hi, I'm Nathalie. Hi.
So she does a lot of organization in the background and also some of the technology. So thank you very much for that, Nathalie. So both will be in the background making this team effort work. If that's okay for the introductions. I also like to let you know that we recorded training to be able to propose it to people who couldn't make the date, and so we'll propose it also at later dates probably. And then I'll just give a few facts about me. I'm also vice president at ARC Advisory Group. And ARC is a consultancy providing technology strategy in manufacturing, and we were one of the early ones picking up the industrial IoT topic. And so I got exposed to that quite early. I was also part of the Industrial Internet in Flanders project, also co-financed by the Commission. I work a lot with industrial end users, with device and product companies, with industry associations, and with organizations promoting industrial internet applications such as Gaia-X, IDSA, Industrial Internet Consortium, the International Digital Twin Association, and a few more. So with all those experience, I gathered what is important to know about industrial IoT. And then at Flanders Make, I managed the project building an industrial IoT platform on which the organization builds prototypes and demonstration applications. And so all that knowledge together, formed my vision of what is important to know. And I put that in this training. And of course, this training is the first of a kind. And we realize it will not be perfect right away. And we're also happy to get your suggestions for improvement, if any. Let me also tell you that I have more material than we can show today. And so there are a few sections that need little explanation, and that is more of reference information. And so I'll go quite quickly over those and provide the detail in the handouts. For those who want or need more explanation on specific topics, we're absolutely happy to organize follow-up calls because we're really committed to help you getting started on industrial IoT. Before I give you the timing details, which are still very much approximate, being this first of a kind, let me add the following. There are a lot of distractions and urgencies around in our world, and which suggests you sort of strike the balance. If you deal with your urgencies, then you will feel more available to listen and participate. So we recommend that you take care of them, get them out of the way, and be present. However, there are many probably smaller urgencies and distractions. And so, I'd like to stress that you have only one chance to be present here today, and that is today. So, if you let the distractions manage you rather than you managing the distractions, then you may miss some stuff. So my recommendation is you stay with us as much as you can. After chapter 2, we'll do an activity that may help you realize what you want to get out of this day, and that may also focus your attention a little bit more. Serena also talked about the Q&A, and I want to stress that if you have a question that is important for you to understand what I'm saying, the storyline, then please ask it right away, and please request a reply right away. So you can raise your hand, use the Q&A, whatever. And the moderator will signal it to me, and I'll try to answer quickly. You can also ask less urgent questions at the end of each chapter. We'll have 1 or 2 breaks in the morning and in the afternoon, also depending a little bit on your needs. So if you feel tired, you say, guys, I have enough. I need a break. Usually that is the same for many other people. So let us know, and we can organize some additional breaks if needed. Otherwise, we'll have roughly 1 in the middle of the morning and 1 in the middle of the afternoon. And then we'll have a lunch break for an hour between 12 and 1. At the end, we'll ask you to express your appreciation. We are required to report to the Commission your appreciation, so your collaboration, that would be really appreciated. And if for some reason or another you would have to leave early, then we'll put a link in the chat so that you can do the appreciation also when leaving a little bit early. That's about it for this introduction. So industrial IoT, an overview for business and technical management roles. We're not going to go in the real detailed techie stuff. We'll start with vocabulary and definitions, and then we'll look at the business potential of industrial IoT, which is really the rationale. Why would you use industrial IoT? And then the next topic is control versus operations management domains. And that explains what kind of applications you can do with IoT and which ones you can't. And so that's important to know before you start. Then there is tactical versus strategic approaches. That's really a decision of how you want to invest, step by step or more deeply across the board. And then we'll look at identity and access management, which has really to do with safety and security, and so also with cybersecurity and governing your applications. Then I want to talk about relevant industry standards for interoperability. It's not only about application interoperability, it's also about interoperability among people, making sure we understand each other and we understand other companies. We'll have a look at the role of an architecture framework or reference architecture. What is it useful for? What can you use it for? And then how do you get organized? How do you organize support and maintenance? What do you do about developing competencies and training people? And then we'll summarize. So that's the content. And as you see, we're not touching on the human part, the change and the emotions and whatever you can encounter. That's a very interesting and important topic that we can talk about another time, but that's not the subject of this training. So let's dive in and look at the vocabulary and definitions. So we'll look at what is advanced manufacturing versus smart manufacturing technologies, and we'll look at what's the difference between initiatives and technologies to make sure that we all talk about the same stuff. If we talk about smart manufacturing, there is also something that is called advanced manufacturing. And advanced manufacturing is really using the advances in science and engineering in manufacturing. And that could be modular production, for example, could be autonomous driving, could be biotechnology. So that's everything from science and engineering, where smart manufacturing technologies is about digital transformation. And one of the items there is the industrial Internet of Things, which we will talk about the rest of the day. And that includes cloud. But it can also IT and automation-based technologies, for example, analytics, or it could be modular automation, which goes with modular production, by the way. Now, we want to distinguish that from initiatives that countries and regions take to promote smart manufacturing. In the UK, you will find the High Value Manufacturing Catapult. In Germany, you will find the Industry 4.0. In the US, you will find the Smart Manufacturing Leadership Coalition, and there are many, 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 many more. More or less each country has its own initiative. But all those initiatives really speak about the same thing, which is digital transformation. They speak generally much less about advanced manufacturing, although that is also still very relevant. We'll see in a few minutes why. So the industrial IoT is somewhere on the boundary of the Internet of Things and big data. And if you look at Industry 4.0, then you would even add the cyber physical systems. And what is cyber physical systems? It is really influencing a physical object or physical asset at a certain distance by an automated control. So here is a little bit more detailed definition. You see it's about an industrial asset on the left with local capabilities, upper right, connected to the cloud, which is on the down on the right. So an industrial asset is usually a cyber physical system. It is something that moves, which is physical, and that we can act upon from a distance. It can be a platform for new applications and services because it has these local capabilities. It is remotely manageable. It's usually part of an ecosystem, and it is supposed to be secure. And it can have those capabilities because it has local compute on board. So it has a processor and storage. It has sensors to monitor how it is doing. It has actuators to act on the moving parts. And it could have software applications such as analytics or agents that inform us of what's going on. And then this is connected to the cloud through Wi-Fi, Ethernet, Bluetooth, or some other connectivity. And it receives instructions, set points, software updates, machine learning model updates over those connections. And it can stream data back to the cloud for our analysis and information. As you see, for example, on the left side, where you see a smartphone app that shows the status of that machine. So summing up, we need to differentiate smart manufacturing from national and industry initiatives. Smart manufacturing is manufacturing applying smart solutions that include the use of recent technologies to improve manufacturing operations. And we'll look at that a little bit more next chapter. We differentiate that from digital transformation. Digital transformation is a much wider, broader concept that also includes the human change and legal and other aspects than just technology. So technology and digital transformation is not the same thing. And IoT is a class of modern technologies, and the industrial IoT is a subset of that. And you can apply other modern technologies in combination with industrial IoT, such as edge, cloud, machine learning, artificial intelligence, and so on. And of course, traditional technologies still play their role, so you can mix and match according to what you need. So next topic, now we know how we can talk about smart manufacturing and IoT is why would you do IoT in the first place? So we'll look at how that is related to economic growth, which is the macroeconomic drivers, and we'll also look at the microeconomic aspects, is how can you influence the bottom line of a company through different mechanisms using industrial IoT. So big question is smart manufacturing and industrial IoT a strategy for growth? Well, actually, that is how it all started, because some studies show that indeed there is a relationship between those technologies and growth, and that is why all these initiatives came up. And this diagram, it summarizes it a little bit. It shows you the change in complexity score of manufacturing between 2010 and 1995. So on the lower side of the diagonal, you see countries that have decreasing complexity technology, and on the left upper side, you have countries that improve in their technology complexity. So they're basically catching up with the countries that are higher up on the scale, such as Germany, Sweden, UK, Belgium, and so on. Now, what those studies showed is that manufacturing resilience, competitiveness, and growth, are correlated with a high degree of technology intensity and technology or manufacturing complexity. So the more, let's say, brain power we invest in our manufacturing, the more competitive and the more resilient our manufacturing becomes. And you see that this is true because on the left side, you see Germany at the top. And on the right side, you see that Germany has the biggest share in manufacturing GDP in Europe. So this seems to be true that the more technology intensity you put into your manufacturing, the more you produce, and so the more growth you have, and the more you develop the manufacturing activity. So it's a very important thing to recall. So basically, high tech in manufacturing improves your chances to sell more and to be more competitive with respect to other countries, such as the countries in the East. Now, if we look at the micro side, so this is basically the equation that calculates the profit of a company based on the main variables. So if we start with the average sales price of the product produced, and we subtract the feed cost, the feedstock cost, and we subtract other variable cost, and we get the net operating margin, and we multiply that with total production, we get the net operating profit. And then we subtract the fixed cost and the capital cost, and then we get ultimately the economic profit. And so it is relatively easy to imagine how we can act on these variables to improve the profit. And we're going to act upon them indirectly by looking to the domains production, quality, maintenance, and supply chain, which are the operations. So we focus on manufacturing, so we will focus on operations aspects. So let's have a look at them, each of them in detail. So if we look at the average sales price, that is influenced by the percent of quality which is first time right. We call that the first quality percentage. So that's influenced by increasing our percentage of on spec, by reducing the scrap. It's also influenced by the product mix. Is the product mix, does it reflect what the market needs? So we need to produce our products in ratios, in proportions that match the need of the need of the market, and that avoids us to store big amounts of stuff that we don't sell. And then the final question is, do we get the price for quality? Can we ask for a premium price for a premium quality? Which in some cases is the case. iPhone is a good example. Technology-wise, it's not so extremely more superior than other products, but you can sell it for a price which is 3 times the price of a similar product. So that's getting a premium price for a premium quality. Let me see, is this the right one? So this is one example. This is quite an old example already. This diagram shows the production area. There are controllers in that production area. We produce Intel chips here, and we have testers, and those testers test if those chips are produced according to specification. Now, it's not only that we produce off-spec, but it's also that the testers are not always reliable. And so what Intel did is they connected their production data to the cloud, and they did some big data analysis to figure out if their testers were testing properly. What they found is they could actually reduce non-genuine off-spec, which is material that the testers would say it is off-spec, but actually was good material. So they would throw away good chips, and they could save 25% of that by doing this analysis in the cloud. And at the same time, they were looking at the performance of those testers, and they were able to maintain them, let's say, less frequently because they had good signals about when they really needed to do that. So that's predictive maintenance. So you can see the number of the savings in total was about 9 million per year. And that is very, very significant. There are other use cases. They could reduce yield losses of soldering processes. They could do image analytics on conformity testing. I don't have the details of that, but you see a few examples of smart maintenance in order to reduce the off-spec, which means acting on this variable and ultimately creating more profit. If we look at the variables, feedstock cost and variable cost, then that's really the price and the amounts of material and energy that we use to produce. So can we reduce that in some way or another? Well, there are many, many examples. This is an example of analytics provided by a Belgian company, Pepite. And they've just been watching the process. They have not been making any really physical investments. They've just been watching the process and making correlations between the production variables and the energy consumption. And they could direct the operators to use the process in a way that consumed less energy than before. And so you see here they get a sustainable gain from that. So the savings are 600,000 euro per year just by putting some software and watching the process and making sure that the variables have the right proportions. We can also look at total production. Basically, if we produce more, we can sell more. So it's all about the utilization of the plant. which is related to maintenance, and it's related to production planning. It's also related to manpower planning. There is an effect of efficiency, so everything that is a slowdown or a quality reduction reduces the total production that we can sell. There could be possibly an effect on demand. If we can make something which is very high in demand, we can sell more. And then there is the effective capacity, which could be related to bottlenecks or manpower and competencies lacking. So these effects influence also total production. Here's a very simple example, which I really like, because it's smart in a way, and it is very, very basic at the from the other perspective. It is basically a detector that detects if the equipment uses current or not, electric current. So we can use this for 50, 60-year-old equipment, which sometimes still is operating in European plants. And we can detect if the machine is working that way, and we can put all those machines in a dashboard, as you see here, and basically we give the supervisor an overview, and he can immediately see if that equipment is running, yes or no. And if it is not running, he can go and have a look and see what's going on. And even that, that changed this company, ThyssenKrupp. This particular ThyssenKrupp division is making very simple, low-cost products, which have real difficulty to compete on the international market. So making this a little smarter and reducing the unplanned stops by about 10% made a huge difference to them. So extremely simple, but extremely smart at the same time. And then we have the fixed cost that we can influence, and that is basically related to inventory amounts and inventory costs. It is related to staff. So staff, basically we'd like to make sure that we increase their added value. They have more time to make good decisions, and will diminish their routine work where where, let's say, machines or software could be more efficient. But where they are really excellent is in making good decisions about maybe maintenance, maybe safety, maybe quality. There are things that you can only appreciate visually. So there are many things where staff can really make a difference. Then there is maintenance. We talked already about predictive maintenance. We can try to reduce incidents by monitoring the status, the health of the equipment. And we can, of course, also focus on quality and production, making sure that quality rises. So here you have an example of the effective capacity. So this analysis, also by ThyssenKrupp, shows that at some point the plant is really saturated. It cannot produce more. So that represents a bottleneck. But there are other moments where there is free capacity. So if you do the proper engineering, then you can probably take away that bottleneck. You will get the next bottleneck, but okay, you will take away a bottleneck. You can overall produce more and get more revenue. In this case, the company could generate 10% more revenue by added value project engineering. This is also a good example of smart manufacturing. This is in logistics. It's Friesland Campina Smart Warehouse, and it's completely automated. So it's full of sensors and computers and AGVs, and so this apparently for Friesland Campina was a real challenge, but finally it worked out, and it worked out even safely. So this is one example where we can automate things and make things more efficient. And then the last item is capital cost. How can we reduce capital cost? Well, by delaying investment. How can we delay investment? By, for example, increasing the effective capacity by small engineering change. Or we can make sure through predictive maintenance that there is less wear and tear and that we have less breakdowns and we have to invest less in replacement equipment. So all that helps in reducing capital cost. And ultimately that you can find the result in the economic profit. Okay, so takeaway. We have a few financial mechanisms to improve profit, improve sales price, improve production value, reducing material and utility cost, reducing fixed costs, reducing capital cost, and we can influence them indirectly by making smart manufacturing applications in the domains of production, maintenance, quality, supply chain, and inventory. And everything that we improve in those domains will ultimately have an impact on those variables, and which ultimately will work out in more profit. So there is a real good reason of doing smart manufacturing and industrial IoT for the, let's say, for the economy of our countries, but also for the economy of our companies. Now, next question is, of course, where do you start? Well, you start where it hurts. You start where you have the highest needs. That's another topic that we could speak about in another moment. But it seems that it's a challenge for some companies to come up with the right use cases. But here you have a starting point, and if you want to have more of our help with that, we're happy to give it. Good. So this should give you an idea of what you could do and how industrial IoT could work out for you. I'd like to suggest you think about it just a few minutes more. So how would you envision the usage of industrial IoT in the coming years in your environment? And how far are you in the journey of realizing that vision? And how does that vision compare to the current state? And which steps would you need to take to reach your vision? And to visualize that process a little bit, I'm taking this diagram from Case Western University in the US in Wisconsin, which is called the intentional change theory. And it says, if you start looking at what you expect from yourself in the longer term, what is your ideal contribution in this manufacturing environment where you are in? You could even broaden it, of course, to other topics. But what would you think you would need to make this a success? And have a look at your at your strong points already today, and also taking into account where you may improve, and you compare that real self with what you expect from yourself, then from there you can derive maybe a few things to learn, and maybe this material that we're presenting here could be one aspect of the things you'd like to learn. And so once you have taken in that information, then you can start experimenting with it and practicing new behaviors, and that will feed back to who you really are. So that's a way of looking at it. Where do you stand? What do you want to develop? What's important to get where you want? So Serena, you're muted, and you want to say something?
Yes, actually, it's not on my account. An had a question. So
Yeah.
if it's okay, I'll just read the question aloud. It's good morning. I had a question on the slide, manufacturing growth and competitiveness. Very interesting data. Is there also data available that compares the European countries to the rest of the world?
Well, not that I know of. And I also have tried to find more recent versions of this study, and I couldn't find them. At least I haven't found them. So I'm sorry to say, no, I don't have that information. The only thing that I found recently was, yeah, there is very often this discussion about does IT and does software and does AI impact employment? And there are lots of people and media that keep repeating that it will reduce employment, but in fact, studies since decades show that it is not the case. Actually, since 100 years, we have been studying the impact of automation in IT on employment, and there is no solid proof that reduces employment. Actually, there are a few examples where it has been proven that it increases employment. Sometimes indirectly, because it increases overall wealth and so it creates jobs elsewhere. But also in the manufacturing space, it can create additional work because it requires people, to develop and use new skills. So that's the only thing we know. But basically, it says that increased productivity through technology also works out positively on employment. And so indirectly, it answers the question that it has a positive impact um, on wealth and prosperity. And that's also true for the US, because some of those studies have been executed in the US. And it is an article that has been published, amongst others, by the European Union. And I can find a reference in the break, and I'll put it in the chat. If you would remind me,
Okay.
Serena, to do that.
Yeah, of course. I'll write that then in my notes. Anne also had a follow-up question. Another question on the economic levers. Are there any use cases where AI has been used as part of obtaining the gains, which is kind of what you addressed already, but I think it's specific to AI.
As part of what exactly?
Obtaining the gains. So basically, like, is there kind of a study that shows that AI leads to economic gains, I guess, in the macroeconomic picture?
Yeah, so then the question is, what is AI? Because we need to define then what AI is. Let's say in manufacturing, we have what I call AI exists since decades. We've been using software optimization in automatic control on industrial plants since decades. This is maybe most obvious in refining and petrochemical applications, maybe a little bit less in chemicals. But even if you look at the use of a smartly programmed, programmable logical controller in discrete manufacturing, it is a form of AI, because it includes historical information. It includes relationships between variables that have been empirically found in that particular manufacturing environment, and it has been turned into a little program that uses that information in a way to anticipate what is going to happen, because it knows how that process works. So from very simple applications, which are PLCs, up to larger scope optimization programs that look at how a plant uses energy. And this example that I gave you, you could consider that an example of AI, because it looks at the relationships of the variables which come out of a plant. It's a matter of automated analysis and providing suggestions of how to operate the plant. So you can consider that also a form of AI. What is called, AI, since the recent hype, is usually machine learning using neural networks. But it doesn't need to be neural networks. It could be other software applications that create that intelligence. So my answer is yes, we're using AI, and we're using it actually since quite some time, but it has become a hype recently, and suddenly it is a big topic, but it always used to be there. Hope that helps.
Well, yes, there's a thank you from Anne, and we're also happy to talk more about it after the course as well.
Absolutely.
Thanks.
Okay, anything else? All right, so back, what you want to learn from this day and how that fits into your plans for the mid long term. So I would say take a few seconds and think about it, and determine for yourself what of this information could be important for you in the coming period. And so you could think of these items that are listed here below. What do you need in terms of competence development, not only for yourself, but also for teams? Do you need to develop a vision and a strategy? Do you need to share that vision with the teams? Do you need to identify who would be the front runners, the people who would, let's say, pull the organization towards this vision? Is there anything you would need to do in investing in hardware, software, and cloud? Maybe would networking with other companies be useful? Do you know somebody who could coach you and your collaborators? You can include all this kind of thinking in developing your vision. So I'll give you a minute at least. Because after the course, you're not going to do it. I know how it works. Is there anyone who would like to share anything he or she found from this reflection? Any new insights? Any actions to take? No one volunteering?
No, I don't think so.
Okay, that's fine too. Good. So let's move on then to the control domain versus the operations management domain. And that will really explain to you what you can do with industrial IoT and what not. The first question that we'd like to answer is, what are the difference between IT, OT, IoT, and operations management, sometimes called MES, in terms of requirements, availability, reliability, security, and functionality, which is quite a lot, and which functions can be best executed in which domain? So first of all, there is no fundamental difference between OT and IT, operations technology and information technology. Basically, it deals with pumping information between nodes. So it's very similar in nature, but there are a few critical differences. The nodes are different because OT doesn't deal with computers, but it deals with instruments and sensors and actuators and so on. And also the nature of the networks and the protocols on those networks are quite different. And also the performance and the reliability of those networks are quite different. So we'll have a look at that. But basically, OT is a special case of IT. Now, what is very specific for OT is the characteristics of the data. So we have real-time or close to real-time aspects. And real-time, the best explanation for real-time that I heard is it's when the plane takes off. It is when it really happens. That is real-time. And many people speak in terms of real-time, in terms of delays. So some processes are very fast, like microchip production, which is in the order of milliseconds. I think also steel production can be very, very fast in the order of microseconds. But it's really how quickly things happen and how quickly we need to get information from that process and get set points and control information back to the process. The other thing is that OT is very high volume compared to IT. So if we talk about information streams with every 10 or 100 milliseconds information flowing, and you multiply that with many sensors, then you can get a feel that there is a huge amount of information. So it's very high volume in detail. It's very high frequency. And often for compliance issues, we need a very long history also that needs to be available. And then there is the data transmission characteristics. So it needs to be fast and deterministic. Now, the opposite of deterministic is a text on your smartphone. If you send a text on your smartphone, can sometimes take a few days to arrive. But often it happens more quickly, but sometimes it's very slow, and there is actually no contractual obligation for it to arrive quickly. However, in industrial control, that's not an option. And so we sort of have a contract which says that the information must arrive within, whatever the definition would be for a specific process, but let's say a tenth of a second, 100 milliseconds, or maybe even faster. On the other hand, we have the requirement that if one application or one equipment has an issue, chokes, whatever is over demand on its memory or compute, then it shouldn't influence the other one. So we need also loose coupling. It cannot influence too heavily other equipment. So that it's a lot of things that need to happen at the same time. It needs to be guaranteed arrival of the information, but on the other hand, it needs to be loosely coupled. We need high availability, 24/7, needs to be extremely reliable also for safety implications. It interacts with operations such as production, maintenance, quality, and logistics, the four domains that I mentioned before. And these can have impacts for people and equipment, so there could be high cost involved if something goes wrong. And it also requires specific skills, specific equipment, specific protocols, specific technologies. So it requires specific skills. So in those aspects, operational technology is different from IT. Now that operational technology and the IT is sometimes depicted in this way. So on the left side, you see the so-called automation pyramid that is split up in layers, and those layers are defined by standard ISA 95. And it starts at the lower level with the physical production equipment, and then you have the sensing and actuation layer, and then on top of that you have the monitoring and control layer, and all that is still very IT and very real time. And then you get into the operations management, which is really a gray zone. Some of it is real time, which means, deterministic, and other parts maybe less. And then above that, we have the business planning, supply chain planning, and business management layers. Now, on the right side, you see actually the same layers and has a little bit more information. And you see also that the time frames change a little bit if you go from below to above. So we start with the milliseconds, microseconds, and then we shift up to seconds. And then operations management, we are somewhere between the seconds and days. And then we go to production planning, where we are between days and months. And then in the business planning, we're somewhere between weeks and years. So the time frames change and the density of the information change. You have going up, you have aggregation, you have less detail, and you have coarser time frames. So we go and zoom in a little bit on the functions in those layers. So if you look at the level 1, sensing and manipulation of the process, that's really where the automatic control happens and where you detect and respond to emergency conditions with safety control functions. And then there is some information flow, coming from the higher levels to execute in terms of set points. And it also, services the man-machine interfaces. So that's really very short-term information. And it should also do some performance diagnostics on itself. And if you look at the level 2, you see the same functions, but it's at different time horizons. So now we're not looking at the last set point, but we're looking at a queue of set points. We're gathering information about the queue of set points to have flow to the production equipment, and we'll also collect and maintain information flowing from the production equipment. So you see that the time frames change a little bit. If we move up to the operations management layer, then we see a number of functions that have been standardized by the ISO 95 or IEC 62264, which includes defining the product recipes or the bill of materials, and then scheduling the production over time based on work orders, and then dispatching that on the equipment, combining it with the product definition and the resources that we need for it. And that combination can then be executed really on the plant floor. And once we have executed, we can start collecting information about the product that we made and about the process, how this went. We can do production tracking and traceability and analyzing the performance. So that is roughly the functions that are in the operations management layer. And here we detail the example for production, but you can do similar functions for quality maintenance and also logistics. So and then we are in the, let's say, hours to maybe days kind of time frames. So that's what happens in level 3. And it's all still operational technology. Examples of operation technology devices are sensors, instruments, actuators, including motors and drives, mobile terminals, barcode scanners, DCS controllers, programmable logical controllers, remote I/O, switches, gateways, edge controllers, edge computers. We have also control networks like field buses and control networks. We have human-machine interfaces, HMI, we have SCADA, which is really data monitoring, we have time series data, historians, we have manufacturing execution systems, and we can have all kinds of applications on top of that, like multivariate analysis, like the energy analysis that I showed you before, statistical process control, plant asset management, managing the different physical assets, maintenance management, replenishment, quality control, quality assurance, process and analytical technology, batch recording applications, plant scheduling, machine control, robot control, real-time optimization, production simulation, or immersive 3D plant simulation. So those are a few examples of operational technologies. Good. Now, with this overview, I'd like to go to make the next step and to show you where the domains are going to blur a little bit. And I'm taking this from work that has been done in the Industry Association NAMUR, which is a German organization, quite international, but still German. A few years ago, NAMUR said, well, you know, this critical control domain, that's very important, and we need to keep it, and absolutely necessary for safe control. But there are some functions that are not time critical, and those functions are mainly monitoring and optimization. You know, we can monitor things and you know, look over time how the health of the equipment behaves. Is not critical for real-time production. So they say, okay, on the one hand, it's the gray pyramid. That's the pyramid we just discussed. It's real-time, it's deterministic, but there are also functions that are not real-time, and those are less critical. There are less safety implications. So we can actually use equipment with less tight specifications. We can use low-cost IoT sensors rather than industrial-grade instruments. And so if one of them breaks, then you know you take your bike, you go to the next store, and you buy a new one. You plug it in, and it can take a few hours. Doesn't matter. So that monitoring and optimization is part of OT. It is part of operations management, but it's sort of the non-critical section of it. And so this is a way to really make that distinction. And they detail it a little bit more in this diagram. So this is again the gray critical area, and then you have the plant-specific monitoring and optimization. And you can do things like dispatching and optimization and alarm management and device management and all those kind of things. And you see that we combine the industrial grade instruments here with let's say cheaper IoT sensors like vibration sensors, for example, that will help us to do some predictive maintenance. And I suggest you can actually do the same at the global level if you have a global organization and collect all that information and do sort of fleet monitoring if you would like to. And you see that one of the critical protocols to connect all this is OPC UA, which is really made for transporting information from and to instruments and controllers. And it's a standard that we also mention in our section about standards. And then the Moore guys, they even work on an additional information model, which is also sometimes called companion specification, and that gives meaning to data that are in the OPC UA information model. So this NOA thing is usually used in the process industry, but I'm showing it to you for the concept. So basically what I'm saying is that we need to separate the monitoring and optimization from the critical control zones. We can even make different security zones from those two zones. One is more critical than the other. We have also different reliability and availability requirements. The critical zone needs to be very reliable, very high grade, very available, where the monitoring and optimization is much less critical. And so that critical piece, you only do that with certified equipment like PLCs, industrial instrumentation, CNC control, edge controllers, and IoT or cloud are not suitable because it's not that deterministic. You cannot guarantee that the information arrives when it must arrive. On the other hand, for monitoring and optimization, you can do that, on premises, in computers, or in the cloud. You could make that private, but you need to make it secure in any case. It's not time critical. It's not deterministic. You can use general purpose IoT sensors. You can combine that with IT-like reliability. Will mostly work. Sometimes will break down. Okay, that's fine. That has a very different price setting. And examples are asset monitoring, predictive maintenance, quality inference, so determining quality from other variables than the quality itself. And you can do that perfectly fine with IoT and cloud with generally much lower cost and lower effort. So that's the story about the domains. What can I do with which technology? So, if you would need to choose, what approach would you use for asset monitoring, or for predictive maintenance, or for real-time process control, or for real-time quality grading? Is there any of those that pose a question? You can share or ask if you want to. So the asset monitoring and the predictive maintenance is not critical, so you can do that with IoT. The real-time process control is critical, so you need to do that with the controller. The real-time quality grading, that's a trap, because it's not critical, but it's close to real-time. You can probably do that on a server and, with less requirements than the control zone. Another gray zone would be, how do you do the control of your HVAC, for example, in the plant? It's still control. Is it critical? Well, stops for half an hour. It's still probably okay. So, you need to make those choices. Okay. I hope this helps you, that gets you started thinking. Let's see. Or maybe we could do a little bit more before the break. Is there any preferences? Any strong feelings about that? No? We'll move on a little bit. So chapter 4 is about tactical versus strategic approaches. A tactical approach would be to use an industrial cloud platform from an automation or an instrumentation provider. So, you buy a few sensors and you get a cloud application with it. You connect that equipment. It gives you a dashboard in the cloud. You can see the status and the values and so on, just as I show here on the right side. Could be, monitoring the location of your trucks or, whatever it could be. So each of those providers have their own clouds. And if you have a few of those, this can be very, very effective for you. It also enables you to test things a little bit, to play with it, to see if it creates value for you. However, if you do this at a larger scale and you have maybe 10 or 20 providers and you have 10 or 20 cloud systems, then it becomes a little bit more cumbersome, right? Because you would like actually to have 1 or 2 dashboards and not 20. So then you may want to think about a more strategic approach and connect everything and maybe do that in your own environment or have a provider create an environment for you. So the strategic approach would be to use your own industrial cloud platform based on hyperscalers. Hyperscalers are Microsoft, Google, or Amazon, or something of of that scale. But that's something that needs careful architecting. It is not really out of the box. So out of the box, you can do some exercises, but that's not very secure, we found. So you really need to architect a secure environment with secure networking and identity and authentication to make that really safe. And to avoid that you do the same work all the time over and over again, we recommend to use automation and templating. I'll touch a little bit on templating. Automation is the automated creation of similar deployments. So make your deployments redeployable and thereby also making it resilient. And probably you will have to work with a partner. There are a few partners who can do this. We in Flanders Make, we were not prepared to do this ourselves, for sure. We knew what we wanted, but we're not able to execute that ourselves. And so we have been working with a integration partner who has executed that for us. And sometimes there is information that people are willing to share. So for example, Flanders Make is willing to share our designs for secure industrial cloud. So, that's not competitive for us. We're happy to share that. So the hyperscalers, the Microsofts and the Amazons, they have their own resources. They have their own functionalities that they provide to app stores. So for example, if you want to store information in a storage account, then each of them has their own flavor. And that disadvantages a little bit the open source alternatives and makes things less flexible and less open than maybe you would dream of. And so there are also alternatives. There are also open source cloud operating systems. OpenStack is one. You pay less, but you also have less support. So there is pros and cons to it. And then, but this is still emerging, I would say. It starts to be operational, but it's still emerging. There is an European sovereign cloud that is being created through the Gaia X initiative. That started as a French-German initiative, but it's really becoming very European. It's even becoming global. The first application on top of the Gaia X foundation is called the Catena X. So that's, Catena stands for chain. It is the value chain in the automotive industry. So it starts with part manufacturers and it ends with the OEM, and it also includes recycling. And it's really operational by now. And on top of Catena X, there are applications or use cases built. One of those is, for example, carbon footprint. Since we need to be very careful about the CO2 that we produce in manufacturing operations, we start also accounting for it. And so if every part manufacturer counts its produced CO2, then it can pass it on through the chain up to the OEM. and that way we can calculate the carbon footprint of the full automotive product. So that's one example, but there are a few other examples. And what the participants of Catena X say is that together they're more efficient in being compliant. There is more and more compliance requirements, and sometimes that is seen as a burden. And of course, you remember um, the protests of our agriculture, but compliance is a real burden for many industries as well. And so what they say is that developing together applications that help becoming more compliant really spreads the burden over more companies and makes it more efficient. And there are all kinds of complementary value chains that are being developed. Factory X is one that deals more with the manufacturing equipment, which is also a value chain, and that of course is connected to the automotive value chain, but also other value chains. And there are more of those. There is Aviation X, there is Manufacturing X. So those are, let's say, more open source type applications that are also available, and that will gain traction over the coming years. That is for sure. Now we have Catena X really operational. I'm pretty confident this will take on. So if you think of an IoT platform, we often think of hub and spoke architecture. And this is what we have been using, but it's very generally applied. On the left side, you have the on-premises network. So this is your manufacturing plant or your lab or whatever. In the middle, this is already in the cloud. We have the so-called hub, where all the connections come in through a gateway and a firewall. And from there, the information is dispatched to the different spokes. So there are only 2 spokes here, but you could imagine many spokes around this hub. And each of those spokes is a space which is private to the people who need to work in that space. We sometimes call it a landing zone, and in that landing zone we can have applications. And those could be maintenance applications, quality applications, production applications, whatever. Applications that analyze what is coming from the plant, and that, based on the data processing, provides advice or information back to the plant about how to operate it. In our case, we made this completely private, so there is no IP address in this space which is publicly known or available or visible, so nobody can access this. But it makes that setting up those applications is a little bit more complex. So it requires some engineering to do that. And as it takes more work to both design and also implement, what we would recommend is to design reusable components and templates. We experimented a lot with connectivities. So we have IoT Edge and IoT Hub to stream data to the cloud. There are all kinds of protocols that you commonly use to do that. And so you can make standard modules for your users that they can deploy, let's say, with a click on a button. There is also file transfer type of connectivity or API, and access through APIs to one of those private clouds that we talked about earlier. it is possible to use open source components or resources. We use some time series databases such as CrateDB or GraphDB or InfluxDB or Grafana. But we found that the hyperscalers don't make that really easy or cheap. So there are pros and cons to it. You don't have to really pay for this, but you pay then somewhere else. That's basically what it comes down to. We also have standard dashboarding and analytics resources and applications, and we use a lot of examples for our users to make it easy to make a variant of those examples. And we use a lot of templates, templates for individual resources and also templates for pipelines. And so a user will copy the resource templates that he needs for an application into one pipeline, and then he executes that pipeline, and that remains stored as such, which means that if the application got lost for some reason or another, there is still the pipeline and we can still redeploy that application because the pipeline is still available. We also make a lot of step-by-step documentation, often use cases and procedures to make things as easy as possible. So all this knowledge that we have gathered is, we are available to share that. That is an example of our list of reusable templates. So for many, you don't need to know the detail, but basically it shows, we have this library and everyone can click on one of those items and then see the documentation and get the section that he needs to copy into the pipeline. And really users are very happy with this. We really recently made a presentation and there was one user in the audience, and I said, okay, is it really true that we deploy a landing zone for you in an hour and you deploy your application in a few days? And he said, yeah, that's actually the case. So if you compare that with making something from scratch, it can take a few months really in the worst case, or maybe even more. So that's a way of working that we have found useful. And all those templates have built-in security and networking rules. That's where the intelligence is, amongst others. So I briefly touched on those open source components. So you need to distinguish open source cloud software, operating systems such as OpenStack, compared to let's say the commercial products like Amazon, Microsoft Azure, Google Cloud. And you need to distinguish that from open source resources. So even on a hyperscaler cloud, you can use open source resources such as InfluxDB or GraphDB. And as I said, they don't try to make it easy for you. What we also learned is that the more managed solutions we take, the easier it becomes. Because the managed solutions, the cloud service provider keeps the infrastructure up to date. So it's being patched, it's being upgraded, it's being maintained. Whereas if you do things yourself, you put a virtual machine that behaves like a PC, you install your application, nobody will look after it. So after some time, those operating systems change, other things change, externally things change, and these things stop working because of lack of maintenance. So the managed solutions reduce your maintenance work. It's a little bit more expensive, but the self-managed solutions require maintenance and some work. So that is something you need to be aware of. Then there is the topic of data modeling and analytics. for data to be understandable, you need to know the context. So basically, if I say 25, it doesn't mean anything unless I say degrees centigrade. Then suddenly it makes sense. It could be an outside temperature, it could be an ambient temperature of your production. So you need to know what the data point means in order to be able to interpret it. And so that is, valid for people, but it's also valid for applications. If I need to figure out a process for my data and try to derive some information from that, I need to know which data point to take. So I need some information, what is what. And to organize your data is really called data modeling. So I'm going to put data into a structure, and that structure has a sort of each element of that structure has a fixed meaning. That's really what a data model is. And so with that data model, we can then start doing data analytics. We can say, okay, let's compare this variable against another variable. Let's see if there is a correlation. What happens if I increase the temperature, then the pressure goes up. Okay, good. So we need that context, we need that data model to make sense out of data, but also to do graphics and also to do machine learning and to do analytics. And we'll see a little bit later that there are many standard data models that we can use and reuse, and that will make interoperability more easy, more cheap, and more standardized. So takeaway, tactical approaches. If you want to do things in a short time, you have limited resources, you will quickly come to an operational result. That's certainly a good thing to do. It can become difficult to maintain over time and to integrate when the number of applications increase. A strategic approach that requires a quality design takes more resources. It can take you more time to bring it to readiness, but it can be interesting because everyone uses the same system and the same standards and the same data models and attaches the same meaning to the same data. Serena, I'll get to you in a second.
Yes, of course.
And it's also the maintenance of complex solutions becomes easier and cheaper when well designed and integrated. If the more standardization you use, the more easy things are to maintain. The more variety you have, the more energy it will take you to maintain. All right, there we go with a question from Serena.
Okay, yes. So I did want to follow up on the first question from Sarina, not me, who asked, may I ask who is the integration partner? Because it's not actually clear what that question is about.
Yes, well, we try to to put plugs in here, but the integrator is Codit, which is a subsidiary of Proximus, and we have found them very, very flexible, they deliver very good service. They are doing very high quality work. We are really impressed by them.
Okay, that's great. So I hope that answers your question, Sarina. And then from Luke van Oefelen, we have, hello, I can imagine from what I hear that self-managing is a no-go, even when your organization is filled with bright, but not really experienced people in this domain.
Well, what I would say you try to avoid it as much as you can, but you will probably encounter situations where people still want to go the self-managed route because they have something very specific that they need, which is not off the shelf available from the provider. So we ended up with a mix. We have some self-managed and we have some managed solutions. We try to minimize the self-managed, but we cannot always avoid it. But your people will learn, of course, as ours do. It's not impossible, but for if you do it in a rational way, you try to minimize it.
Okay, thank you.
Anything else? But let me add maybe that I went, the whole range from extremely simple to extremely complicated. What we have been doing, we have now more than 30 different landing zones with probably even more applications in it, which would be really exceptional for a company. Even a larger company would be quite big. So make your choices depending on really what you need, and if you feel you need to brainstorm about it with us, we're happy to provide you some additional support. But don't get the impression everything is extremely complicated, which is also not true. There's so much information already available and that we can share, so you shouldn't feel alone with it. Okay. Good. So what about a little break at this point?
Yep, I think we're ready to go. Yeah.
Okay. Chris, I'm not sure if he left already. Okay, the feedback link was there. Good. Sorry. We're ready to go? Yes? Okay, fine. Everyone can see my screen. Everyone can hear me. All good? So to come back to that past chapter, so what's your vision now for using industrial IoT for strategic or tactical approaches? What would you choose? What would be most logical for you? Or would you start maybe with tactical and then experiment a little bit and then transition to strategic? And if you would extend the question to smart manufacturing, would that change the perspective? Comparing pure IoT, which is a more restricted scope, to a more broad approach to manufacturing. Serena, I think there was a question by Anne, or was a hand by Anne. Did I see that correctly?
I don't.
You don't see it?
No.
It may come back.
Okay. Yeah. I think that you're seeing the previous question, unless Anne does have another question. And if not, do we move on, or should we take a little bit of time to maybe think about our visions for IoT, and we can maybe share it in the chat?
I'd like that. I think we're doing very well on time, so we can afford doing that. So
Okay, so maybe you would say we want to first address the strategic versus tactical, especially because it's a simple binary question. Would if you are already using IIoT, do you think your approach is more strategic or tactical?
that's also a good way of putting it.
Or maybe a little bit more wake up time?
Yeah, or maybe people are shy to speak up,
Yeah, it can be.
Which happens.
It's a full classroom, so I can imagine.
So as Flanders Make, we went for most of the strategic approach. That's for sure, and we're reaping the benefits from it now. But it took us a few years, and so that's and it there have been moments in that journey that have been really difficult, and we've really been doubting: are we doing this the right way? Yes or no? Are we still on the right path? In the end, it turned out all to be very, very efficient and very, very well done. So we're very happy about the result. But we recognize that the long road is not the easiest road for sure. But okay, this experience is also available to you. So that's the positive about it. Maybe we can get back to the vision if you like,
Yeah.
Serena.
Yeah, I think so. So I think we can go proceed with the next topics.
Oh, you want to move on in the course? It's also possible. I thought you wanted to go back to the vision story, but all
Okay,
fine.
yeah.
So in the original plan, this was the last chapter before the lunch. Things we're doing a little bit better than expected, which is fine. It will take off a little bit of time pressure. We may finish a little bit early, so that's how I see it now. And we certainly have time for many questions. So this could be maybe a little bit dry and technical, but it's an important topic. It's really about security. That's really the point. But just to explain the basics, I like to explain the difference between identity and authorization. So the identity defines who you are through authentication. So basically, you use your name, your password, and you have some two or more factor authentication to make sure that it's really you. And I'd like to take the opportunity to tell you about the usual approach versus the European approach, if I may call it that way. So the usual approach is that the service provider or the product provider keeps your identity. So your username and password is stored with that provider. And basically that means that you need a username and password for every provider and for every bank and for every application and so on, which makes things a little bit more complicated than just having your passport in your pocket, because you manage that. You manage your identity. And so that letter ID is the idea that has been used by the European initiatives such as Gaia X and stuff that builds on it, which makes that you own your own identity and you come to some environment or some application and you use your identity. So that's totally different, and it will probably create some revolution. Anyway, so once we know who you are, then we can decide what you can do based on the role you have. And you may have multiple roles in multiple applications, We call that often role-based access control, or RBAC for short. Now, so far that's for people, but we need the same thing for software and devices. We also need to make sure that if a software performs an action on some other software, or if a device performs an action, think of an AGV that wants to provide data to your cloud environment, it also needs to identify. So works slightly different, but it's the same principle. The hardware would have a hardware key built on top of it, which is, not accessible to anyone that manipulates that equipment. Is really an integral part of that equipment, and that enables it to identify in a unique way. And for software, we work with certificates and access keys. And those access keys are stored in secrets vaults that are not accessible to people or to very limited number of people. So that's still a safe way to make sure that also software can identify itself. And one example is, for example, an agent. So if we have a cloud application on one part of the cloud, and we have a development environment such as DevOps or GitHub, which is another part of the cloud, we use an agent that deploys what I have defined here in this development environment, and that starts realizing it in my cloud environment. And so it needs to identify who it is and what it can do. And so that is an agent, and that agent has certain, is identified and has certain rights to do certain things. So it's it's true throughout the board. Now, the principles of authorization is really to grant only as much as needed. It's a little bit a difference with, or a break with, traditions that we used to have, and that used to be a little bit more easygoing. But today, with all the cybersecurity risk that increase in danger and increase in frequency, we need to be more rigorous. So we would provide read access to a user in the zone and the application that he needs to use or access. We would provide read, write, delete access to the zone in the application and the resources that a developer uses. We would provide read, write access to a project manager to the zones of his project. So it could be wider scope, but smaller set of rights. And we would, of course, give read, write, delete access to administrators, and even not only the zones and applications, but also to the platform functions. And in some cases, we provide that access to, so that really broad and powerful access to administrators only for a certain period, to make sure that if someone hacks his account, that authorization is not available all the time. So that reduces again the risks. So we try to limit the access in terms of scope, application zone platform, and as little as possible, and also as short as possible, but as long as needed, of course. So user accounts basically should be able to do what is needed for operations. Now, very often, users used to have admin rights to equipment. And those admin usernames and passwords used to be, very widely available, sometimes on post-its to the equipment and so on. That's the kind of thing that we cannot do anymore. It's unfortunate, but that becomes a real security risk. And security risks also are related to safety risks, because if your equipment does things that they're not expected to do, it could also be in safety issues. So it becomes more and more critical to manage that authorization. The access through the cloud network should be just as secure as the access to the physical device and just as secure to the IT on-premises networks. I'll get back to that in a little bit. So on-premises networking, our IT organizations usually have the IT part of that networking pretty much under control. That's usually working well and is usually fairly safe. Where we find the most weaknesses is on the OT side, although IT is not always perfect, but on the OT side, there is these admin access to equipment. Sometimes we lack network control points, such as gateways and firewalls. Not everyone may have a demilitarized zone, which is a zone that separates the office networks using a network control point from the production networks. And so the real good modern practice is to define the network zones that you want to apply. And for each zone, you define the security level. And for example, those security levels can go from 0 to 3, and those are expressed in safety integrity levels, which are defined by the IEC 61508 standard. And basically that, the SIL 3 is the highest security level, that is the most highly protected zones, that is critical, for example, for safety control. And the SIL 1 and 2 levels are also important. They are also critical in the sense of time-critical operations. And that's usually the production control zone or zones of other functions related to production, such as quality, logistics, and so on. So, depending on the zone, depending on the criticality, we can assign the level of security that we want to apply. And the higher level of security, the more difficult it becomes to access those zones. And in the case of the protective zones, that access may be not existing at all. So that's at least the policy of some companies. And then we define conduits between the zones by defining ports in the network control points. So that's a way of reducing the risk and reducing the access to a very small pipe, reducing the surface, so to speak. Cloud networking is similar, I would say, in nature. So we have, again, zones. We make sure that people have access to zones where they have a task and don't have access to other zones. We apply the same zone and conduit analysis and separation. We use the identity and authorization management with role-based access. We apply the layered authorization, which is, people get access to the layer that they need to have access to. And we make sure that we have a high resilience. So if something goes wrong, which we try to make as unlikely as possible, we still have the information in the pipelines that enable us to redeploy what we have developed before. So we have always a memory of what we have done, and we can also redeploy that if something would go wrong with our application. So cloud networking and on-premises networking is very similar, although we don't have the safety aspects in the cloud. We only have the security aspects in the cloud. Then to increase resilience further, it's not a one-time thing. It is really a continuous risk management program that you need to build. And you need to, well, we would recommend you to follow an applicable guideline or framework. And we have the luck in Belgium that we have the Center of Cybersecurity who provide a framework. A framework is largely based on the US National Institute of Science and Technology, NIST, cybersecurity framework, which is very well crafted. And the CCB has extended that with very tangible, actionable items to look at and to improve. So it's really very well done. And basically it comes down to start with making an inventory of the software and devices that you have, to map the network, divide it in zones as we just discussed, define the conduits, the links between those zones, attribute security levels to those zones, and compare in how far the security you have compares to your design. So and assess the compliance compared to what the CCB recommends for your type of industry, because it depends on what type of industry, how strict that standard is. And then we would recommend to set priorities, in particular for OT, but for all topics. Look at what you can patch and remediate where needed. And I'm saying where needed because you may have some isolated zones that nobody can access, and so you don't have to patch them either. Define and implement your policies. So very simple things. Make sure everyone and every equipment has a secure password that is changed regularly. Make sure that where it is critical that the USB ports are disabled, because that's a source of infection. Make sure the firewalls are configured in a proper way, in a secure way. Make sure you have your patching and vulnerability management strategy. And your patching strategy could be, I need to patch it now because it's critical. I can patch it later because I can make other defenses for this environment. I will not patch it all because it's not needed. It's an isolated section. And you could consult with, in an automated way or not, with advisories who list the well-known vulnerabilities. Now, that doesn't protect you against not known vulnerabilities, but it protects you at least to most vulnerabilities. We're in contact with the German government, who are developing an interface to a global advisory, and we're trying to learn from them, and that will enable companies to access those vulnerability databases in an automated way. Because if you have a large installed base, it can become very cumbersome to check those databases very regularly. Another thing that we've been doing as Flanders Make is to develop automated analysis of the code in a pipeline that people use to make embedded software solutions. We're doing that in particular specifically for the small and medium-sized enterprises in Belgium. And we provide some advice to them how they can use their deployment pipelines and do the analysis at the same time, and also compare with those vulnerability databases. That's our IoT SBOM Cook project, and we're happy to provide more information about that for interested companies. So we talked already about the admin access to equipment, so we need to restrict that to selected administrators, and maybe even make that temporary. So elevate their rights during a certain time to do a certain operation, and take those rights away again. And we need to talk about implementing secure IT coding practices. That's what I just mentioned in relation to our IoT SBOM project. SBOM stands for Software Bill of Materials. So Bill of Materials is usually applied to a physical product and contains all the components and materials used for that product. If you do that in a software environment, you look at all the software components in the application. So we looked at all the equipment and software that we have. We looked at the obvious vulnerabilities, and we did some remediation. Now we need to become a little bit more systematic about it. So we recommend to implement an iterative improvement program. Keep comparing your current state with your target states. And in every loop, let's say every year, make improvement iterations with respect to your security target, with respect to new vulnerabilities and new attack approaches. Make sure that you have management in the loop for approvals, because according to the new legislation, they are responsible. And include governance, which really means review and improvement of the policies and the policy enforcement. So in a diagram, you get, the first stage is look at your foundations and do some remediation, and then do an improvement loop where you do an assessment, an implementation, or maintenance update, and then start over again every now and then. Cybersecurity guidelines and regulations. So on the IT side, we have the ISO 27000. That's the IT cybersecurity. Then we have, for combined IT and OT security, we have the IEC 62443 standard. That's quite a bunch of information, but it is very well written. It gives really good recommendations. It gives an emphasis on methodologies, on how to do things, is really useful. Then there is the NIST cybersecurity framework that I mentioned before, is also about combined IT and OT security. That focuses on domains and subdomains, the inventory and remediation actions, and particularly the Belgian version of the CCB is very useful and simple to use, so that I would recommend. But for a little deeper analysis, you can go to the NIST CSF if you want to. And then there are other publications like the Industrial Internet Consortium publication about security framework and IoT security maturity model, which are focused on IoT. And then for the cloud, there is the Microsoft Cybersecurity Framework for Azure Cloud, and I'm sure there will be comparable frameworks for Amazon and Google, which I have no detailed knowledge of, but I really expect there is something similar available as well. So I think in terms of standards, that's probably where you can start with. Now, I started reading my way through all these standards and guidelines, and I found that they all more or less depend on each other. So they're all sort of interrelated, and it all comes together in the Cyber Fundamentals framework of the CCB. So, if you want a concise summary, then that's really a good place to go. So the ISO said 27000 is more IT. And then you have if you add the Microsoft Azure Cybersecurity Framework and maybe the Center of Internet Security, CIS, that also includes IoT. And then you go further to the right, you get the IT and OT combination, both in the 62443 and the NIST. And that all flows into what we have in the CCB. So, ultimately, you have everything in CCB, but for more detail and more depth, you can go to the other ones. Um, the next piece of this chapter is about the EU cybersecurity regulations. The two most important things to know about, I think, is the NIS2 directive for operators and the Cyber Resilience Act for technology companies or vendors, if you will. And the two interact. And so they are a directive. This too is a directive, which means it has to be translated in national law, and in that translation, the nations can make little tweaks. So each NIS2 has slightly different, but largely the same, comparable to the overall directive. The NIS2 directive will be active starting next October, and there will be a period until November 2025 where companies have the opportunity to become compliant. And basically, it says that industrial companies and other critical categories need to be cyber secure, and they also need to have their management involved in making cybersecurity related decisions, which includes training people and giving them the means to become cyber secure. Now, companies could have the obligation to be NIS2 compliant, or they could have the obligation to become NIS2 and CRA compliant. The Cyber Resilience Act obliges companies that provide technology, software or hardware or combinations of that to deliver cyber secure products and services, and they need to maintain that cybersecurity throughout the life cycle of those products and services. So there is a maintenance activity required. And there are also obligations for both parties to report about incidents. So if an operating company has a cybersecurity incident, it is obliged to report it to a cybersecurity response team. And so it becomes publicly available, and the technology companies need to monitor those incidents and make sure that they remediate any issues that are related to their products or services and provide patches and solutions to their users who are the operating company. So you see how the two interact with each other. The Cyber Resilience Act will be will require compliance a little bit later than the NIS2, but both are coming up pretty quickly if you compare it to the work we have to do. At Flanders Make, we started analyzing what we will need to do for the NIS2. It's not totally impossible, but it requires some thinking and analysis and inventory work and decide on new policies and make sure everyone knows about them and implement them and so on. So it takes a little bit of time. So that's the short version of the EU cybersecurity regulations. In the handout, there is a little bit more detailed information. And I really recommend you look at the CCB website. That also gives you a spreadsheet that you can use to, there's a checklist with all the actions that you could take depending on the criticality of your environment, and look at the measures you can take to become compliant. That's a spelling error, organizating, but this transparency tries to make the point that the security regulations, IEC 61508 and 61558, require for you to have a person responsible for security And that person needs to be independent of the technical organizations such as the IT and OT organizations. So they cannot really report to IT or to automation or to engineering. Then should, according to the regulation, they should report directly to the management levels. And that is to make sure that that they can speak up freely. They can also veto certain actions proposed by IT or OT, such that security becomes the highest priority. And the same thing is true for safety, actually. Today we speak a lot about CISO, which is Chief Information Security Officer. And so those CISOs are separate from CIOs. That's the recommendation. And the security and safety people, they should also be, they should have, they should be able to veto, and they should also be able to overrule any decisions made, for example, in production, in IT or in engineering. Takeaway here is that cyber resilient will consume some effort and budget. However, this is a good investment because it's far cheaper to become resilient than to pay for the damage. If you have damage, it can mean outage for days or weeks. It can mean that you will have an army of IT people to save your situations. It can mean that you lose all your data. It can mean that you're liable for data, that the data of your clients or your personnel leaks away, and that you may have to pay them for that damage. It can be really extremely costly. So it will consume effort and budget in the long term, but it's definitely a good investment. There are really useful guidelines to help you becoming resilient. There are well-crafted frameworks to test your resilience and compliance. And there are, of course, many people who also go the same path. So there is a good reason to work with your peers or work with other companies who are doing the same things. We are working with also a comparable organization, which is more in life science, but we have the same security challenges, and so it's really useful to compare notes and to work together. Okay, I think Serena has a hand here. You're muted.
Hello, yes. I thought I would catch us up on questions. We've had a few over the past few minutes.
Okay.
Certainly I think maybe we're going to do the first question first. So from Luke, we have, can you define what a landing zone is?
Yes, it's true. I use a few terms. So we often speak about this hub and spoke architecture. So you can imagine the hub and you can imagine the spokes that are around. And a landing zone is something, is a private space where people work on their applications. And it's called a landing zone because everything in between your PC or your computer and that landing zone is invisible. You don't see what happens in the hub. You don't see what happens in the firewall. You don't, that's all invisible, but you will land. It will become visible when you land in that space, and that is why it is called a landing zone. So that is where it becomes visible. I hope that helps. But basically, it's an isolated private space where you have applications.
Okay, I hope this is helpful for Luke. It certainly was for me. Now for the second question, which is from An. Something that strikes me in your list of tools, I don't think I have seen any ERP systems such as SAP or Odoo. Do they have a place in this industrial IoT, or are the other tools better?
That's I like you asked that question, Anne, and it's true that I've been concentrating on. Let me get back to maybe this diagram. That's the only place that mentions the ERP really. So if you look at this diagram here, the top of the triangle is the business management. That is where the ERP is. There is a sort of a competition between people with products in the operations management and in the supply chain and logistics space. That would compete with solutions in the
Valentin, I think we can't see anything being shared. Now the
Oh,
presentation.
that's funny. How come? Not sure how it comes, but thank you. So here we are again.
Thank you.
Okay, so briefly, you know, the ERP, and this should go to slideshow normally. Yes, okay. So ERP is in the top here. This is a standard way of viewing functions. Functions do not necessarily correspond to what is implemented in software. So let me make this clear maybe a little bit with the following. I'm trying to improvise here real time. So in my ISO 95 documents, I should have an overview that would help you, hopefully. This one is maybe best. No, this one is not good. Okay, give me 1 second more.
Okay, I know we're a little bit ahead of schedule, so we definitely have time to do this.
This is where I need to be. Here, I'm sure I have this information. It is really coming directly from the ISO 95 standard. There should be an update, I don't know. Okay, anyway, good. So this is a little bit older. You can see from the design, it's a little bit older, but this is the point. So you will recognize the ISO 95 functions. We've been looking in the presentation at the production functions. That is this small pod here of production functions. So this is level 3. Level 2 is below. Level 4 and 5 are above. We have the same thing for maintenance, quality, and inventory. Now, if you look at what software providers deliver, they go over the boundary of the levels. So if you look at what ERP applications deliver, usually there is not much about production in there. Usually, not saying always, but most often there is not much about production. But there is sometimes functions in terms of maintenance. For example, maintenance scheduling and maintenance resource management. So that may be present in SAP. Odoo, I don't know personally in detail, but you know, could be as well. And you will also find quality functions. At least for SAP, I know that it has quality functions. And so in the quality functions in level 3 of that ERP, even if you associate it with level 4 or 5, it has functions in level 3. And in the functions level 3, the IoT might be useful. So if I have an IoT application that tests the quality, that provides me information in this function to say, this piece you have produced is on spec and the next piece is off spec and needs to be recycled and so on, I could use an IoT application to do that. So some ERP vendors have functions in level 3 for which they can use IoT. And the same thing is true for the inventory on-site logistics, and the same may be even true for level 4 logistics and supply chain management. And frankly, for the financial and HR, I'm not very experienced, but you could imagine that, for example, you would measure exposure of people to hazardous environment, maybe nuclear radiation or other toxic environments that you would directly couple to the HR modules in ERP with an IoT application. So it's a long story to tell you that there may be meaningful IoT applications for ERP level 4 and 5, but also for ERP level functions in level 3. But it's true, I haven't emphasized those.
Okay, that's a great answer, and it's great that you had just the right slide. Thank you.
I have many slides. Okay, anything else? I'm seeing
sorry.
Geert Ostein asks a question.
Yes, another question. Just
so Geert
yeah,
says,
I
I couldn't follow the whole session, but as far as I can judge, you didn't mention a lot regarding the need of a trusted and effective backup. Without this, you're lost in case issues happen. Yes, absolutely true. So yes, you need absolutely. Now, I'm doing that on purpose because I don't want to step on the IT domain, but even the OT data that are stored in IT equipment need to be backed up. So that's, yes, absolutely true. And there is other, aspects that help resilience that I mentioned before. But yeah, absolutely, Geert, thank you for the comment. Useful for everyone, I think.
Yep, indeed.
Okay.
Any more questions? Okay, all right.
Good. So we move on for another half an hour, roughly. So as far as I can see here, we're more or less half an hour ahead of schedule. Good. So maybe I can go a little bit more in detail about the standards for interoperability than I originally planned to do. The role of industry standards, we talked already about the security standards, but I'm talking about other standards here. But also for those security standards, the same purpose. Basically, they avoid to reinvent the wheel, to design stuff that is already known, and to learn from what others do. Basically, to stand on the shoulders of the people that came before us. And in that, we gain time and effort in design and engineering. Specifically, if they contain information models, they improve interoperability between and among devices and software. Let me give you a very practical example since we have a little bit of time. I'll scroll back to this slide that I showed you before about the operations management and control domains. This big. So here you have an example. So we have the critical control here on the right side. We have the maintenance, the monitoring and optimization on the left side, and we want to use sensor or instrumentation information to do processing and to make decisions, to get information about the health status of the equipment, or maybe the quality of what we produce. So we have an instrument here which is dark blue, and we have the OPC UA protocol. The OPC UA protocol is basically a very open environment in which we can create any data structure that we like. But that data structure does not have a meaning unless we define it. And so, yes, we can engineer it, we can define what the meaning of our data structure is, but we can also reuse a standard data structure that has been defined by someone else. So in this case, it's the more open architecture information model, but it could also be an OPC UA companion spec for whatever equipment. For many types of production equipment, there is a predefined data structure. So you don't have to invent it. And the advantage is that not only you understands it, but also the equipment provider understands it. So that makes that you can more easily exchange about this information, and it becomes basically cheaper to engineer and easier to use. So that's a very practical example. We can, this is a very low level example. There are also very high level examples. If we want to describe the asset hierarchy of the whole plant and equipment, there are also data models to do that. So we don't have to invent them. We can basically reuse what other people have defined. So get back to where I was, which is here. So we gain time and effort in implementation. We gain time and effort in maintenance. We improve the interoperability between devices and software, but also between people and organizations. The scope of industry standards can be IT, can be OT, can be IoT, can be IIoT. So there are different scopes, of course, out there. And we would really recommend you to use those standards to build data modeling, data models. And remember, I talked a little bit about data modeling to illustrate what it is useful for. And adopt a data model provided by standards organization, again, saves you time. The categories that I believe are useful are standards for asset management, standards for IoT architecture frameworks, the Industry 4.0 related standards, control and operations management standards, and safety standards. And I'll take the time to flip through a few of those quickly since we have some time. One that is very well known in asset management is the ISO 19526. And basically, it helps data integration, sharing, and handover of asset lifecycle information. And you can think of interactions between an engineering company, the operating company, a service company. So everyone speaks the same language and uses the same data structure. There are also more detailed standards for planned change handover between engineering and operations and for exchange between operators and contractors. And for example, the 19526 is used by many software companies in asset management, but also in ERP. For example, SAP also uses that standard to model the structure of the assets of a owner. Then there is standards for buildings and infrastructure, in particular the British standard or PAS 1192 that you may want to use if you have many buildings to manage or want to manage your buildings in in a rational way. There is the Industry 4.0 asset administration shell, which is quite a modern concept. And it has a standardized description of physical assets and specifically used for smart manufacturing. And it has a certain number of sections. One of the sections will become an obligation soon, which is the identification section, which is really the sort of software nameplate, if you want. And then there is other sections which with general technical information, manuals, maintenance information, operational information, all kinds of other information that is called submodels. And here I provide a link to for you to do some more reading about that. But basically, that asset administration shell is a sort of a software description of the asset, and it can be used to exchange, again, between the asset builder, the equipment builder, the operator, the main maintenance company, the service company, and so forth and so on. So we could imagine that as an extension of those distinctions that we mentioned before between the critical operation information and the non-critical. It is typically non-critical, but is also standardized, and it can also help exchanging. There is the ISO 14306 for standardized 3D visualization of CAD design. There is IoT architecture frameworks. Different organizations provide their own frameworks. The one that I like, that I find very complete, is the one I used a lot. Is the FiWare framework. Maybe I could show it. Do you think, Serena, I have time to show it?
Yes, we also have a question, but you can show this first.
Oh, yes, please. Yeah. Well, while you ask the question, I'll try to find the framework.
Okay, maybe we can do that. Yeah, so this is from Anne, and it's how do you handle the asset management from a financial perspective? So once depreciated, they don't exist anymore, and the operational and security asset management.
Okay, that's a good question. So yes, it is true that there are several aspects to asset management. There are many asset management applications that focus really on the maintenance aspects, and they become more and more smart. So now we can predict when we need to do maintenance. And as we can predict when we need to do maintenance, we can also predict which parts we need to order to do that maintenance. That is usually, as far as I know, not yet integrated with security. Not even with safety, as far as I have seen. Usually those are separate activities. And it's true, it needs to be synchronized with the financial life cycle. So if an equipment is written off and you want to continue to use it, you need to continue to maintain it and to manage that asset. That could be a favorable situation because it doesn't cost you write-off anymore, but it still produces. But of course, your ERP needs to know that it is still there. It needs to be still in your inventory. But it's not something that should be written off. Now, on the financial side, somewhere I have my limits, so I'll duck here. I couldn't make you more recommendations, but it's a good thing to look at with a financial expert. So it still needs to be on your books as an asset, but it could be a written off asset. So it still needs to exist somehow. That's my take. But this is an interesting question, for sure.
Yep. Thank you.
Let me see if I can find not easy. Let me see. Architectures. I'm getting very close here. Okay, here it is. So this is an architecture framework that I've made that is largely inspired on the FireWare architecture framework. Basically, it shows everything that could be possible in terms of OT equipment. It could be control networks. It could be edge compute. It could be lab and business networks and servers. It could be ERP, operations management, asset management. It could be design software, and how this all connects and how it is linked to the cloud. And in the cloud, I make two distinction between, let's say, the foundational software and the applications. Applications that the user uses, landing zones, if you will, and the underlying software. So it looks maybe complex, but it has all the options in there that you can think of. And now people can start drawing, data applications and flows on top of this, and they can say, okay, if we have this information, then it can flow there, and then we can do this with it, and we can provide it back to the equipment, and then analyze it again and show it in the cloud. And so that is the use of such a architecture framework, that you can use it to design specific architectures for specific applications. That's the point I'm trying to make with this. I've taken FireWare, but you can take anything else. The Industrial Internet Consortium provides frameworks. IDSA provides those frameworks. There are a few other ones that could be useful. Cloud providers have their own views. They are maybe less technical, maybe less manufacturing, but they can also be useful. And then there is a ISO standard that defines how you can define such an architecture framework. And the Industrial Internet Consortium reference architecture, the IIRA, is ISO 42010 compliant, and the architecture framework that I made for Flanders Make is also ISO 42010 compliant. And basically that implies that there is a structure to it. In my case, that structure is by persona. I think we're coming back to that point somewhere. Then you have the control and operations management standards. You have the OPC UA protocol. You have the ISA 95 that defines the interfaces to the ERP and the functions in the level 3. You have the ISA 88, which is really modular control. Can be used for batch control, but also for other modular software design. There is the ISA 100 for wireless networking. There is the Namur open architecture that I mentioned before, just for completeness. There is the basis 4.2, which is a standardized description of equipment capability for industrial interoperability. So very Industry 4.0 oriented. May not be very well known yet, but it will gain in importance over the coming years. And then there are the safety standards. There is one overarching 61508 that I mentioned already before. I don't know it in detail, very honestly, but this diagram will show you which ones may be relevant specifically for your situation. Probably the general and the machines, maybe the automotive, maybe rail, I don't know. But in any case, it gives you a starting point if you need to study safety standards. Good. So that is my summary of the most important industry standards for interoperability. So it may seem a little bit overwhelming, but really it saves time and effort to get to operational readiness. And custom development has really proven to be inefficient and costly to maintain. So it seems attractive in the beginning because you control everything and you know everything. You don't have to plunge into an ocean of not known stuff, but ultimately it's efficient to use those standards. But of course, you would use a gradual iterative approach and start using pieces and extend that. And for sure, delegate it to domain experts and make sure you audit and control what's going on. And definitely participate to consortia or work with peers so that you share information and share how to use those things. Sharing application know-how, definitely a time saver. So here's a reflection for you. What would be the impact of not using international standards? And what are the pros and cons of developing your own standards? And how can the latter complement the first? Would you decide on using standards or request a recommendation by your teams? That's a leadership question. So if you use international standards, then of course you have an improved understanding of what companies internationally do and how they do things. So it gives you more access to more players. Developing your own standards, of course, you control everything. Disadvantage is that you need to put effort in maintaining them. How can the latter complement the first? Well, in some cases, information models do not cover everything you need. So you could use a standard information model from a standard and then define some extensions, which will still limit your effort and make you more efficient. So my leadership approach would be to get advice from your teams, inspire them by the great principles and directives, but also get their input. Okay. Role of the architecture framework. We started already with that. I think, Serena, I think we can break for lunch unless we have any questions.
Yes, indeed, we can take a quick break for lunch. And are there any questions before we do so?
I think they should.
So I think we changed the settings so that if you also would like to speak rather than write, I think you should be now unmuted.
Okay, good.
Okay, all right. Well,
so in case you
thank
need to leave, don't forget to do the appreciation from the link that we put in the chat. We would be very happy to see you back after lunch and go through the last chapters. I think we're really ahead of time, so you will be out of here by 3-ish probably, as far as my feeling goes now. So that's
Yep,
probably
and-
good to start the holiday tomorrow.
Okay, perfect.
Thanks, Anne. See you.
Then, yeah, we'll see you again at 1 p.m. And we'll have a few more moments for interaction as well then. So if you have questions, there'll be lots to talk about. Thank you for your attention.
Thanks a lot. See you later. Bye. So an architecture framework or reference architecture is really the same thing. To make sure that we're clear about that. And it should be much more than a diagram, much more than a diagram that I showed earlier. It's really an explanation about the content of that diagram, how it fits together, what meaning it has for different roles, for different persona. And I like the ISO 42010 standard to describe reference architectures. And it describes it using different viewpoints, and it does it in a general way that allows you to create architectures from the framework. But it defines the rules, it defines the constraints. So, for example, it will say about a one family house that it will need to have a living room, and it will need to have sleeping rooms, and it will need to have a kitchen, and it will have at least one bathroom, but it doesn't specify how many, and it doesn't specify how they should be organized with respect to each other unless there is a specific constraint. So it sets the general perspective, the general rules and constraints, but it doesn't specify specific architectures. So those viewpoints could be the business viewpoint, the user viewpoint, the developer viewpoint, the administrator viewpoint, the maintenance viewpoint. But you can also organize it differently. For example, the business viewpoint, the technical viewpoint, the functional viewpoint can have different ways. You can construct it in different ways. That gives the overview of possible architectures, the possibilities. It hints at the possibilities, rules and constraints, as I said. And it should help teams designing an architecture. So it should also contain information about how do you go about to use that as a basis and to go from there to an architecture. So usually people will start with a functional architecture, so they will describe the functions that they need, something like collecting the data, storing the data, transmitting the data to the cloud, analyzing the data, that kind of information. And so the guidance in the architecture framework will guide them through how to do that, and will also provide them examples. And will help them in transforming it into a compliant, feasible architecture. And it could be supported by administrators or a center of excellence. And it could also have detailed documentation to help those functions. So here's an example. So first we make a functional design. We use the guiding principles from the reference architecture. We get something like this, something similar to what I showed you before. We collect the data, we transmit the data, we store the data, we analyze the data, we provide the analysis to someone who can use it. So that's a functional architecture. Then we need to translate the functional design to an architecture that we can implement. And we use the standard resources from the reference. And usually it's good to provide some help through the Center of Excellence team, from the documentation, from peers. And so we need to transform that functional architecture in this kind of implementable architecture. So this is an Azure architecture, but it could be also an Amazon architecture, or it could be another cloud architecture. But this shows the same thing in a different way. We still collect the data, transform the data, analyze the data, and provide some view on it using an analytics application. In our Flanders Make architecture framework, we also provide tutorials. We have implemented this in Azure DevOps, if you recognize it, in wikis. And so we have example applications, and one example application is deploying a storage account, and we show screen by screen how people should do that. And we have some other examples documented. We have that for deploying a website or function apps. We have it for container instances. We have it for machine learning. We have it for uploading data. So for the most often occurring applications, we have tutorials that show step by step how things work. So architecture frameworks provide guidance, rules, and constraints in building architectures. They can be structured according to topic. They can be structured according to persona. They can include documentation for platforms used for architecture implementation. That is about architecture frameworks. And so don't hesitate to take an existing architecture framework and build on that. Again, there is a lot of information available that you can reuse. Okay, is there any questions so far? Nothing that I can see. Then if not, I'll continue with organization, support, and maintenance. So in some form or another, a center of excellence or support center is useful. And even if that's big words, it can be simple. In the case of Flanders Make, I support it from a more strategic point of view, and I have a colleague who is in IT, who is the administrator, who does the more technical things. We're both part-time, but for a moment we can very well manage this support for the organization. And we help the users in architecting. So first of all, helping them in formulating their ideas and their needs, and then transforming that to functional architectures, real architectures. And then we help them more technically to deploy that. Sometimes we run into lacking modules, so we work with the integrator to provide the module that they need. We help them with troubleshooting, first line support, and then we have second and third line support, which is managed by the integrator. We also provide them information about training and the documentation that we have. We maintain the documentation because things keep changing, things keep evolving, and we liaise with the second and third line support to escalate issues, monitor the resolution, follow up the maintenance and development activities. There is continuously small development activities to provide initial functionality that the organization needs. The second and third line expert support, I would say usually it is externalized unless you're a really large organization often provided by the integrator. The hyperscalers don't provide that kind of services. They provide fourth line support to the integrators, by the way. You will have service level agreements with them defining the priority, the response times, and the costs related to that. They can monitor hard and soft policy violations, so warnings and hard stops. They will monitor the impact of managed service updates, similar to patching on your PC, upgrades, operating system upgrades, that kind of thing. If there's any changes that need to be implemented in terms of the application upon a resource change, then they also do that. And they implement platform extensions or modifications. And it is absolutely necessary to have good teamwork between the internal and the externalized function. So the better relationship you have, the better things will work. Then there is a need for regular reviews by management. And so, we made a big investment and other companies will do the same. So you will need to monitor the usage. You will need to monitor the ROI, the benefits. You could make dashboards. We do that too, to monitor the cost, the usage, the benefits, the security levels. And you can use that to adjust and correct, for example, by doing internal information sessions to make people aware, especially in our organization with a lot of growth and turnover. We constantly need to inform people about our platform. We also issue some newsletters. We build tutorials for often used functionalities, and that keeps growing and evolving. So that's more internal view, I think, review and correction. There is also the support reviews where we look at the tickets. If there are any tickets that stick, that don't get resolved for some reason or another, you need to monitor the platform and the application development to see if we need any modifications or enhancements. You need to manage those enhancement projects and communicate about them. Hey, community, we have a new possibility now. You can do this or that. And then we do some management reporting, and management must be involved to some degree, at a minimum, to make decisions about security and to provide means that will enable people to maintain security. So those are these NIS2 and CRA obligations that we talked about before. So organization support and maintenance, the takeaway is that some structure is absolutely useful. Make sure you provide all the functions that people need in terms of consulting and support and maintenance. Outsource the second and third line support if that makes sense. Usually it will. Create a management process for regular tasks, such as governance, rules, reviews. What kind of resources are allowed? If people use very expensive resources, when do they get a warning? When do they get cut off? In order to avoid budget issues. Same thing for security. If people deploy applications that are dangerous in terms of security, then they should also get warnings or maybe get stopped. Monitoring the platform features, monitoring cost, usage, ROI, benefits, and then management and organizational communication about the platform and about what is achieved, and where they can find resources and so on. So here's a suggestion for an activity. Take a moment and think of an organizational model for your support, maintenance, and cybersecurity related to any IoT you would think of in the near future. How would you organize that? Would that be one person? Would that be a small team? How would the security functions become independent of the existing engineering and IT organizations? What is common, what is different from the diagram that we show? We have already shown, but we repeat it here on this page. Would you use this organizational form or not? Where would you place the support? In the IT and in engineering or elsewhere? Do you need an adaptation for a large or small organization? Would you need any help? So we were a little bit a big group to do group activities, but I'd recommend you to think about it if you get started. Is there any question or thought? Is there anyone who wants to share his thoughts about this? Nobody? Okay, folks, I think we're going to finish this even earlier than I thought. So that's the organizational design. So anyway, if you have any thoughts about this later and you want to chat about it, we're happy to exchange views. So the last piece is competence development. Competence development or training. There is a difference between skills and competence. Skills is an ability and competence is a palette of behaviors that are intentionally used in situations to specifically achieve something. So it's a little bit more complex. So I don't know how it works in your organizations, but in most often the manager and the employee establish an annual development plan, also related to the performance evaluation, and probably also related to the tasks ahead as they are planned at that point in time for the rest of the year. So you could include IoT and cloud competencies within that development plan when required for tasks and projects. And you have many options for learning. You can use public learning sites. Microsoft has a Microsoft Learn site where you can do all kinds of programs for different types of roles. It's really very detailed and it's very well done. You could organize sandboxes where people can play around, specific to the company. You can watch tutorials, you can document tutorials. You could have a secondment by an experienced person. You could have coaching by a Center of Excellence member. So there are many different options for learning. What we recommend is you use learning profiles. We have some standard curricula for different personas, such as users, developers, administrators, security experts, and so on. And so in preparing those curricula, you can think of which percentage of the time do those different roles spend on training? Is there any room there? Do you need to reshuffle something? For whom would this be really a priority? Where is it important to put emphasis? Where is it important just to create some awareness? So you can construct that in a way that makes sense for your organization. It is really, I think, important to realize that these fields of OT, IT, cybersecurity are really fast moving. And so we need more training. We need also more continuous training than we used to need in, let's say, engineering topics that don't change so quickly. You should also think about what you would like to intend to change or to achieve, and where the training is useful, and also tie that to the personal objectives of those people. So that's the kind of things I'd suggest you to look at. Okay, so I'm through much earlier than I ever had dreamt of. I hope that's good news for you. So the summary is that we looked at vocabulary and definitions. Basically, we said IoT is a specific type of equipment that has onboard capabilities and that is connected to the internet, specific class of equipment. It has business potential for the industry, but also for individual companies. We can act on certain financial levers by improving processes in production, maintenance, quality, and logistics. We need to distinguish the control domain where time is critical and determinism is important versus operations management, where monitoring and optimization happens, which is not time critical. The latter domain, we can use IoT, we can use cheap IoT sensors, and we can use the cloud, where in critical control we can't. You can think of a tactical approach or a strategic approach. Tactical would be to rely on the cloud dashboards by your providers. A strategic approach would be to construct more of a holistic cloud environment for all usages. You need to be careful about security, and so manage carefully identity and access. Restrict that access as much as possible, but give people the possibility to do what they need to do. Monitor the rules and make sure you enforce the rules that you define, and make sure that you're compliant in terms of cybersecurity. Not in the least, the European regulation, NIS2 and CRA. Use relevant industry standards for interoperability at the lower technical levels, also at the higher levels. Use an architecture framework to design functional and implementable architectures. Make sure you organize in a way that support and maintenance have their roles and that users are consulted with, and make sure users and developers and administrators get the right level of competence to do their work. So with that, is there any remaining questions? I see something in the chat there. Look, that's a whole story.
Yeah,
Do you want to speak up, maybe?
Luke, if you'd prefer to, or I can read it. Okay, I don't hear anything.
Okay,
so
sorry.
I'll read it, and if you want to read it yourself, you can interrupt me. We are busy implementing IoT for devices that are set up external to the company. Also, customers and owners of those devices are allowed at the end to get access to the devices and or to the gathered data in the cloud via a viewer application. You spoke about security during industrial manufacturing, so on premise, but my example goes a step further. Do you agree this poses an extra challenge? And if yes, what is this challenge from your experience with its attention points? Thank you.
Okay, that's a good one. I love it. I think to a certain extent, we came across this situation because Flanders Make works in a network. And so we have, let's say, the main mother organization, and we have all kinds of laboratories in different universities. So you could compare that to your clients where you have your IoT devices installed. Well, maybe let me get back to the diagram that I had somewhere earlier. Let's see. It's a very interesting question because I think there are probably more companies with clients also included in the ecosystem. So if you look at this diagram, it's actually very generic. So on the right side, we have our cloud, right? And the cloud is then the central hub and the different workspaces or landing zones. On the left side, we have the on-premises, but these on-premises can be multiple on-premises. So it can be your own company, but it can also be your clients. So if your clients connect in a secure way, if you want to connect everyone to the same cloud, let's assume that for a moment. If your clients connect to your cloud in a secure way, for example, using VPN, virtual private networking, and you set it up as a site-to-site VPN, you can filter out the zones where they can work in. So with their identity and role-based access control, they get filtered out and they can only work in the zone which is relevant to them. So if you organize some application, maybe or a website or a dashboard or whatever you do for your clients, they can only go here and experience that application. And that is true for all your clients, but it's also true for your own sites. You could also think of separating your cloud from your clients' clouds. That may be another thing that could be possible. But I think even in a single architecture, you can realize that as long as you create a secure connection, you should absolutely require a VPN connection, because then you can manage the security inside your cloud. That's sort of the only way that you can use to identify who someone is, and then based on that you can define his rights.
Okay.
Is that I'm not able to take the microphone. Okay, no problem. Anything you want to add, Luc? Okay, so that's helpful.
Let's wait for, wait. I think we need, let me see if I can,
Yes.
we can allow Mike. Okay, I can, you should be able to unmute yourself, Luc.
Or here, no. Yet Ostein wants to say something.
Yes.
He has a long question.
Yes.
And then
do you hear me?
after here.
Yeah.
Okay, yeah. Yes, we can hear you, Luc. And then
It's Geert now.
Geert, you're next.
Yeah, okay.
Well, maybe a slightly longer question, but do you have any experience on how you built the organization with an IT and an OT team? Because the request of the skills they have is slightly different.
Yep.
And we see often in companies that there is a kind of, I would say, obstruction in both directions. We have seen that if we can make people rotate between IT teams and OT teams, that is already an advantage. But the goal of the OT members is slightly different, or their interests are slightly different than the IT team.
Yeah, that's absolutely true. Well, I have studied this for a sort of an industry best practice study. So it was about, basically it was about OT. That was the focus, but we looked at how the interactions worked with IT. And we looked at all kinds of organizational forms. Maybe I can look it up if I can find it. Can show the presentations. Okay, you give me a sec, I can look it up. The most recent one. Not sure if it is the right one. We'll see. Maybe I'll have to change presentations. It's not the right one, but can try this one. November 17 is a recent one. That's all. Give some clues, but not everything. So we looked at all kinds of combinations. Does manufacturing IT look at both IT and the manufacturing and automation? Yes or no? Is it governed in the same way? Are they governed together? Are they governed separately? So we looked at all the possibilities basically, and we also looked at all the organizational forms. So you can have central IT, you can have IT in the business units, you can have the same for the OT. It can also be centralized or in the business units or a combination of that. You can also put them together or keep them separate. We looked at all the different possibilities, and basically the result of the study is that one organizational form or another, statistically at least, does not give any difference in performance. What makes a difference in performance is if the organizations talk with each other, if they exchange views, if they collaborate, if the management talks to each other, if the objectives are set for the organizations in consultation with each other, if they regularly meet, that is the most critical part. So if you put them together, yes or no, it's not critical. The most important thing. So I think what you say about rotation or cross training, I imagine that makes a difference, because basically it means that people get in contact with each other and develop empathy for each other's viewpoint. But you can do that also in different ways. You can also create teams, for example, where they have to work together on one specific task. So suppose you have a new initiative, a new equipment, a new production line, or maintenance of some, and you put them together in a team to deal with that specific topic, then they will have to work together. And as management, you can facilitate that. So if you are aware of that effect, you can stimulate them talking to each other. You can detect if they don't understand or don't want to understand, or maybe they have some aversion, or maybe they feel insecure in the presence of the knowledge of someone else in another domain. So you can facilitate that exchange. But that's really the critical part. But you need exchange among the teams, but you also need exchange at the management levels. That is my recommendation. So that's what we found.
Okay, thank you. With our experience was that definitely without discussing about the organization, but if the people are regularly sitting together, so that at least they know each other, not from a phone or from a screen, but
face to face.
that they can work together and that they have the same objectives. Because if the objective from the department is different from the general objective
then
or
they
the
start
common
working in
objective,
opposite
then there
directions.
is an issue. Yeah.
Yeah, perfect. Thank you. A good, interesting comment for everyone. Excellent.
Okay. Thank you, Geert. Very thoughtful and very interesting discussion. We also have a question from Mohsen, and he can unmute himself. Mohsen? Alternatively, if he's typing, hello?
Hi, thank you for
perfect.
unmuting my mic. I'm not sure if you hear me very well or.
No.
Okay.
It's
I just wanted to add some point to the Luke question about having external devices for the company in terms of security. So I added my point in the chat. I think there are some security considerations regarding physical access or damage to the devices, or even physical attacks to the devices or the infrastructure. So in my opinion, there should be also some considerations to avoid these kind of vulnerabilities. For instance, if we have some sensors in a farm for agricultural application, we should regularly check the devices to see if they are collecting data in a proper way or not, or even if there are some breaches in the network or other things. So I just wanted to know your point and your comment about this.
No, I fully agree. We skipped over it in the earlier discussion, but you're absolutely right. So the security rules that are applied on the site where the IoT sensor is needs to be of a similar level of what you want to achieve in your cloud. So you're absolutely right. The rules that you apply to yourself should also be applied by your client. The physical access and even the measurement conditions. You're also right that the sensor need to be in good conditions to give good results. There is more and more health information included in sensors today when you purchase them. So a part you can do as device management centrally. So you can observe those parameters from your central location. But it may be good to go also on site and have a look how things are used and make sure that they're used properly. I think it's completely well described what you say. So yeah, thanks for your perspective.
Thank you. Thanks for your response.
Yep. Thank you. Other questions? Everyone can now unmute themselves. So if you want to ask, in a spoken way, also you can write in the chat or the Q&A if you'd like.
You can sing a song, whatever.
Yes, I can break out into song, write your musical about cybersecurity, etc.
Okay.
Right. Then perhaps we'll send the feedback form before we say our final goodbyes. This is for our Reboot Skills program. This is the first course that we've delivered, so your feedback is particularly critical to the remaining 20-ish modules that will be coming up. So if you can fill out the feedback, then you can have a say in how our future courses are structured. So it's kind of you choose what story you want to listen to. That was another question. Okay, there is another question.
The feedback link. No, it's the feedback link again. Oh, there is a question from Philip.
There is another feedback question. Yes. Okay.
Okay.
So, sorry, Philip. People weren't using the Q&A question, but you're the renegade. So from Philip, if you're still here, you can unmute yourself, or I'll read ahead. Which tools do you use best for making ARCS framework?
ARCS framework. Let me read.
Yeah, I think he's referring to the slides, your slides from other conferences.
Yeah. That's an interesting question. Well, to be completely frank with you, I've been using PowerPoint, but I think if you are fluent in drawing programs, maybe you can use something more sophisticated. So that's really for the diagram. I use the wikis in DevOps to make the text document. I started with Word, but I found it absolutely ineffective to make iterations and improvements. So I started cutting it up in pieces, and I put it in a wiki. Now the wiki can reside anywhere. It can be in DevOps, it can be in Confluence, it can be I should say Confluence, I think. It could be on some Microsoft site, whatever. I think that is very modular and easy to change and manage. So that is something I recommend. But everything that fits your needs and fits your company system. It could be a document management system. It could be a PLM system. It could be whatever suits you. But I found Word not very practical, but for the diagrams, I use PowerPoint, but I think there are better tools for that. I see Bart has shared his black screen. It happens to me too. Bart, did you want to say something?
No, I just have a look how I can switch it off.
Sorry. Okay, no problem.
Yes.
No problem.
Okay. Other questions? Any email questions on your side? No. As you may have seen in the chat, we shared the feedback form again. So if you can fill this out while we say our parting, please fill it out.
And please, if you have little time, just do the first two questions. That's the most essential for us. And at least we have something to rely on to report back to the commission. But we would be happy to see more if you have the opportunity.
Look, this is a very good question. If you can also unmute yourself and ask, because indeed, we can support you quite a bit more. I don't hear from Luke, but he has written down, how can we further use your organization? How far does your support stretch?
In very general terms, we provide advice but we also provide, let's say, support with projects. Usually, it's proof of concept, or it is a sort of a first of a kind, and then usually companies will transition to, let's say, more professionalized versions. But we do sort of the early exploration, proof of concept, proving that things work out for you, and show you how you can do things, and then from there you can get started with, let's say, rolling out or scaling up. So it can be quite extensive, but it depends a little bit on the topic, how far we can go. So please, get in contact with us, and we'll tell you what we can do, what we can't do. We will be very honest about it.
Yep, indeed. We're a combination of a research organization and a technology transfer organization, and we, a fundamental reason of why we exist is to support you. So
Exactly.
don't be shy about asking questions.
Yeah. Okay, I think we'll leave everyone the opportunity to do their appreciations. I can stay around for some more time.
Let's keep this open until 2, and then, as mentioned, Natalie just also added our contact form. You can contact us anytime. You should be able to contact us also through this chat and continue the conversation if you should wish to do so.